probability, the and or rules. So first of all, when talking about probability, it's important to know the difference between an independent event and a dependent event. So I'm going to write down what the difference is now, and then I'm going to run through some examples. Okay, so here we have the definition. So an independent event is an event where one event happening doesn't affect the other event happening. So, for example, I came up with a weird one, but that is, so the probability that Wales win the Six Nations doesn't affect the probability that you get a 9 in your GCSE maths exam. Different events don't affect each other, or a more, basic one that they use would be probability of me throwing a 2 on that dice doesn't really affect the probability I throw another 2, or so each throw is independent of the last throw. So me throwing a 2 at first didn't actually affect what I was going to get the next time. It doesn't mean I can't get a 2. The probability of getting a 2 is still exactly the same. So I hope that's okay. So dependent events are, it's kind of what you'd expect. So they're events that depend on other events. Not they depend, but their probability is affected by that happening. So for example, the probability I have lasagna on Monday affects the probability I have lasagna on Thursday, because I'm probably not going to be likely to have lasagna that soon after I've just eaten lasagna. Does that make sense? So yeah, the probability of one event happening affects the probability of another event happening. So the probability that it rains today probably has an effect on the probability that it rains tomorrow, because if it's winter or whatever, you're more likely to have bad weather, probably in rainy season or something. So they're the examples I came up with. So it's just so you know what they are. Okay, so this is the and rule. So it's the probability of event A and B happening. So probability of event A happening and B happening is the probability of A multiplied by the probability of B. So in stats, and, the English word and, means multiply. So don't hear and, hear multiply, basically, from now on. So the probability of A and B. So we're just going to put this to use with my dice and money here. So I'm going to do some things, and then I'm going to work out the probability that actually happens. So I'm going to toss this coin, and I got a head. So I want the probability of getting a head and getting a head. So that is the probability of getting, so if we look at our equation, the probability of getting a head and a head, so A is head and B is head, is the probability of getting head multiplied by the probability of getting another one. Okay, so first of all, we need to work out what is the probability of getting a head. When I toss a coin, the probability of getting a head is 1 out of half, because I can either get a head or a tail. So this is the number of ways I can get it, and this is the total outcomes I could have got. So this is just going to be probability of a head times head, half, multiplied by a half is a quarter. So the probability of me actually tossing those coins and getting what I got was a quarter. Let's do that again. Quite fun. Okay, so I've given it another go. So now I want what was the probability I got a tail and a head? Okay, so I know that is the probability of getting a tail multiplied by the probability of getting a head, because in stats and means multiply. So first of all, let's work out the probability of getting a tail. This one is a half, because I can either get a head or a tail. Same with this. So that is a half multiplied by a half, which equals a quarter again. So surprise, surprise, it's always going to be a quarter if I throw 2 coins, but there we go. Let's do another one involving our dice. Okay, so I'm going to toss a coin and roll a dice. So I don't know if I can multitask like this. Or do it separately. Okay, so the probability, I got a 1 and a head. Okay, so what was the chances I actually just performed what I just did? So that is, so we know it's and, so we know it's multiply, so it's probability of getting a 1 multiplied by the probability of getting ahead. We've already worked that out. We know the probability of getting ahead is a half. What about the probability of getting a 1 when I throw a supposedly fair 6-sided dice, which is also multifunctional as a rubber? So probability of getting a 1 is, there's one way I can get it out of 6 options. So it's a 6th. And that comes from the equation, the total ways you can get that event divided by the total possible solutions that could have come. Okay, so when you multiply fractions, you multiply the top and you multiply the bottom. So the probability that I just did what I did was a 12. Let's move on to the OR rule. Okay, so this is the official sort of equation for the OR rule. So the probability of getting event A or B is the probability of getting A plus probability B minus probability of getting A and B. But if those events, if A and B can't happen at the same time, so if it's not possible to get A and B, that is 0. So quite often our equation is just, especially for foundation, so OR means add in stats. So quite often we just use our equation this way because most of the time the probability of A and B happening is 0 because they can't happen at the same time. So OR means add. So if you've got A or B, you do the probability of A plus the probability of B. So now let's move on to some examples. So I'm going to toss this coin. So I'm going to go with the probability I get ahead or tail. Okay, so we know from our equation, we know both of these can't happen at the same time. You can't get a head and a tail. So the probability of A and B happening is 0, so it's just this equation here. Because you have to get one or the other. I don't think coins land like that. So you get the probability of a head plus the probability of getting a tail. And we know the probability of getting a head is a half. And the probability of getting a tail is also a half. So we do a half plus a half, which equals 1. So it's a 100% chance of getting a head or a tail. Yeah, that does make sense. I toss a coin, I either have to get a head or I have to get a tail. Let's try it with a dice. So the probability I roll a 4, remember this is a very much a fair 6-sided dice, or a 6. Okay, now we know from our equation we're going to use this one. Plus, so probability of 4 or a 6 is probability of 4 plus probability of 6 because OR means add. And we know we don't have to subtract this bit because you know you can't roll a 4 and a 6 at the same time because we're only using one dice. Like maybe if I rolled them both, but I wasn't. Okay, so what's the probability of getting a 4 is there's 1 4 out of the 6 options, and the probability of getting a 6 is there's 1 6 out of the 6 options. So we know that this is a 6th plus a 6th, which when you add those together, same denominator, so you can just add the numerator, is 2 6ths, or that is equivalent to 1/3. So again, there's examples of the AND rule. So AND means multiply, cannot stress that enough, or means add. You only really have to worry about this if you're higher tier, and also doesn't normally matter, and just think, can these two things happen at the same time? But mostly just this one, or means add, and means multiply, and hope you enjoyed my examples. I feel rich now.